Okay, a proton and an electron exert a force of 1,680 newtons on each other. Calculate the distance between their centers. So we know that the force is 1,680 newtons. And since it is a proton, which is positive, and an electron, which is negative, we know that that's an attractive force. So that's a negative 1680. Alright, and the Q, the charge of an electron, is 1.6 times 10 to the negative 19th coulombs, and that's a negative charge. And the charge of a proton is a positive 1.6 times 10 to the negative 19th coulombs. And our Coulomb's constant is still 9.0 times 10 to the 9th newtons times meters squared per coulomb squared. And if we're looking for our distance, that's our question mark. So our equation, F equals K times Q1 times Q2 divided by D squared. If I'm solving for D, the first thing I need to do is get D out of the denominator. So I need to multiply both sides by D squared so that it's no longer in the denominator. It cancels out on this side. And so I have F times D squared equals K times Q1 times Q2. Now, if I'm solving for D, I then need to move my F over here, so I'm going to divide by force on both sides so that forces cancel, and you're left with D squared equals K times Q1 times Q2 divided by F. Now I don't want D squared, I want D, so I need to take the square root of both sides. The square root of something squared cancels that out, so you're left with D equals the square root of K times Q1 times Q2 divided by F. So we need to figure out this before we take the square root. Square root's the last thing you do. So we're going to go ahead and plug in our numbers. D equals 9 times 10 to the 9th times 1.6 times 10 to the negative 19th times the negative 1.6 times 10 to the negative 19th, all divided by a negative 1680. And then we take the square root of all of that. Okay, now when you're plugging this in your calculator, since you have a negative on top and a negative on bottom, you know that those negatives are going to cancel out and you're going to end up with a positive. So you don't really have to worry about plugging in the negative in your calculator. It'll make things a whole lot easier if you don't. Just leave it positive. So that means I have 1.6 times 10 to the negative 19th times itself. So that's essentially 1.6 times 10 to the 19th squared. Okay? So that's how I'm going to plug it in my calculator. I'm going to do 9 times 10 to the 9th times 1.6 times 10 to the negative 19th squared, and that equals that 2.304 times 10 to the negative 28th, and then I need to divide by 1680, and that gives me 1.37 blah 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 blah. So then I need to take the square root of my answer. So my distance is 3.7 times 10 to the negative 16th meters. That's really, really close. There you go.